Hello my dear friends. So I'm making this video for all the electrical engineers who want to understand the fundamental concept of electrical machine. So all the electrical machines have stator and rotor component. So on these stator and rotor we place magnets. So these magnet could be the real one, the permanent magnet, or they can be also created by coils, electromagnets. So here this magnet is on the rotor and this magnet is on stator. So we can draw the magnetic axis of these magnets. So the stator will be like this and the rotor will be like this. We can call it phi r, we can call it phi s. Now these rotor magnets will be pulled toward this stator magnet. Okay, and this phenomena in electrical machine is called the electromagnetic torque, the torque of the machine. So this torque will depend upon the strength of these two magnets, which is obvious case. So it will depend upon phi r and phi s, as well as it will depend upon the angle made between these phi r and phi s. So which is also called the load angle. Okay, so any load will be having a requirement of the torque requirement. So this machine we regulate the machine torque such that the load torque is equal to the load torque, electromagnetic torque, and the machine starts running at a constant speed. If we talk about DC machine, what happens, we have a magnet set of magnets on the stator which are stationary in space, and we have got magnets on the rotor. But the beautiful part of here it is that the magnet on the rotor is always stationary, no matter what the rotor position is. The magnet axis is 90 degree to the stator magnets. So how this is possible? This is possible by using the commutator and brushes arrangement. So I will make a separate video for that, but here we can consider these two magnet axes as to be perpendicular to each other. So here the theta is unregulatory, so theta is 90 degree by the construction, and we can regulate our phi r and phi s to develop a sufficient torque for the machine. When we talk about induction machine, it is somewhat different. Induction machine is quite different because here we do not create the rotor magnet, we do not put excitation to for the rotor winding to have permanent magnets. Here we have got only the stator magnets, and what we do, we just rotate this stator magnet with some speed, and therefore by Faraday's law the rotor is induced with some magnet, and as soon as the rotor is induced with magnet, a torque is experienced by the rotor. So it accelerates the rotor to such a point at which the machine develops sufficient torque which is equal to the load torque, and at that point the machine starts rotating at constant speed. When we talk about synchronous machine, one more very unique machine. So in this machine what we do, we rotate the stator magnets as well as the rotor magnets, and they both rotate at the same speed such that the theta could be regulated to develop sufficient torque which is equal to the load torque. Here the theta is called the load angle of the synchronous machine. So these are three fundamental machine which I have just mentioned, and the whole concept is to generate a sufficient torque. So uh, if there is any more doubt, you can just ask in the comment box, and I'll be ready to answer you. And if you like this video, kindly like and subscribe. Thank you.